All right, on example number 2, we have find the surface area of revolution about the x-axis of y equals 6 sine of 6x over the interval 0 to pi over 6. And my pen is not working. There we go. Okay, I found it. All right, so I know you can graph this equation because we worked on it last year. So let's look at what that's going to look like. Okay, we have a sine function. So the sine always starts at the midline. It's not moving up or down any. So our sine function is going to start at the midline. The highest it's going to get is at 6. And the lowest it's going to get is at -6. That's our amplitude, and then our period is going to be 2 pi over 6. So at 2 pi over 6, which I know that's pi over 3, but it's going to help us here in a minute, 2 pi over 6. Then that's going to make our halfway mark at pi over 6. And from 0 to pi over 6 is exactly what we're looking for. So let's go ahead and draw out our sine function. Starts at the midline and goes up. Then at halfway, it's going to go back through the midline, all the way to the low, and then back up. So that's one period of our sine function. So the amount that we are looking at is just this amount right here, from 0 to pi over 6. So we can reflect that down about the x-axis. And so what we have is kind of this little pearl or walnut shape that we are going to find just the surface area of. So this is different than our volume. We are just finding our surface area. If we did take one of those pieces out, it would just be a circle. So for one piece, it is just the diameter that we're looking at. So our surface area equation we talked about in the last video is equal to the integral from a to b, in this case from 0 to pi over 6, times the diameter, or the, sorry, did I say diameter? Circumference. The circumference of one piece, which is going to be 2 pi, and then the height of that is the function, so 2 pi times f of x, which is 6 sine of 6x. And then we have to multiply that by the whole length, which is the length of the line, which we have to use the integral of 1 plus f prime of x squared to find the length of that line. So let's look at this. We need to find y prime. So we have 6 sine of 6x, and then to find the derivative of that is going to be 6 cosine of 6x, and then just don't forget your chain rule, multiply it by the derivative of the inside. So our final derivative is going to be 36 cosine of 6x. And then we'll put that in here, and then we're going to have to square the whole thing. So, no. 36 cosine of 6x all squared. All right, there we go. Let's rewrite a little bit. We can pull this 6 out from in front of that and the 2 pi. So we have 12 pi, 0 to pi over 6. Before, when it was still in this format, the way that I did it before on this notes is I actually set this 36 cosine of 6x equal to u and did a u substitution. And you can definitely do that. It is actually kind of nice because we're going to plug this into our calculator to solve. So you can plug it in like this. I'll simplify a little bit. But it is actually pretty nice, and maybe we should look at it that way. Let me go back here. Undo. My 12. Okay, let's go back here and let's just look at that. if we did a u substitution here, because it was really nice to put into my calculator that way. So we have 36 cosine of 6x, and then find du. Du is negative 36 sine of 6x times 6 dx. And then we already have this 6 sine of 6x is all right here. So that could be set equal to our du. And then of course we should have a dx out here, which I forgot. And so we do have that much out there. So all I would have to do is say that dx equals negative 1 over 36 of du. So that is really pretty nice and makes it pretty nice to put into your calculator. Biggest problem is that now you've got to go in and redo your limits of integration. So plug in 0 for x here. So we would have to do our limits of integration. So we would have u is equal to 36 cosine. First we would plug in 0. So cosine of 0 is positive 1. So we would get positive 36. And that's when we plugged in 0. Then, for our next one, we would plug in pi over 6. So 6 times pi over 6. Which would then be cosine of pi, which is negative 1. And then negative 1 times 36 is negative 36. And so we would have this, well, let's just write it all out and then I'll show you what happens. So we have the 2 pi out in front, and we didn't use that 2 pi anywhere. And then our limits of integration, the bottom one became positive 36 and the top one became negative 36. But what we have here is this negative 1 over 36. I think I got an extra negative in there. And so we got the 2 pi. This all goes away with the du and the dx. And then we end up with the square root of 1 plus u squared du. Then, remember quite a while ago, we talked about, at the very beginning of doing integrals, that if that you could do the opposite, so we could make that a positive, and then switch the signs on that integral. So that is a little bit of an integration trick that you can do. It's not a trick, it's proven, but that is something that you can do. Then you have an integral that's easy to put into your calculator. It's way easier than plugging in the other equation. So either way that you want to do it, if that u substitution is too confusing for you, don't worry about that. But if it's not, if you can go through and quickly do that in just a few seconds, it will really, really cut down on what you have to put into the calculator. And not only that, but it'll really cut down on any missing parentheses, any mistakes. You're a lot more likely to get the correct answer. Well, you'd have to do the u substitution right, but I liked it better. That's the way I did it. And then you will come up with your final answer. Let's see, pi over 18, yep, 227. And thank you. So surface area equals 227.028. And that's your example number 2. Okay, I do have a couple examples I'm just going to go through here really quick. It's mostly just setting up because, again, you're going to be doing these on your calculator or online somewhere with an integral calculator. But I really like the pictures that they show. Of course, you'll see them in your homework as well. But I think it really shows the images really well of what exactly we're doing and finding the surface area of these objects. These are not volume. That's why our equations are so different. So here we have y equals 3x cubed. They've done a really good job of graphing that there for you, putting in that graph. And then what happens is that graph gets revolved around the x-axis, and you end up with this nice shape right there. So to find that surface area, our surface area is going to equal the integral from 0 to 2.5 of 2 pi times f of x, which is 3x cubed. And then we're going to need to know y prime here. So y prime is going to be 9x squared. And then the integral of, square root of 1 plus 9x squared squared. So make sure you get 2 squareds in there. And then dx. Alright, doing a u substitution on this one did not really help me any. It was easier to just go ahead and put, it was just that sine one that really helped. I just went ahead and put in everything just like this into my calculator and found the integral of this and evaluated it from 0 to 2.5. And then your answer for this one should be squared 6,906.148. And that's your surface area. On example number 4, we have let C be the curve y equals the square root of, or 5 times the square root of x, and they give us this picture here, for the intervals from 1.8 to 3.5. So between these two blue dots, and then it is revolved about the x-axis. Yeah, what? Okay, I'm back. Alright, so we have this little line right here being revolved around the x-axis, and we get this beautiful shape. And we need to find the surface area for that shape. So find the surface area of the area of revolution about the x-axis of R. And I can't fit everything on here, so we've got 5 times the square root of x. Try to remember that. And so we've got y equals 5 times the square root of x, and we are integrating from 1.8 to 3.5. So we've got the surface area is equal to that interval times some function dx, where f of x, in this case they're saying what is the whole equation that we're going to integrate. And so that's going to be 2 pi times the function f square root of x times the square root of 1 plus, we need to find the derivative, so y prime equals, that's going to be 5 halves times x to the negative 1 half, which then simplified is going to be 5 over 2 root x. Okay. And then inside of here, we will have 5 over 2 root of x all squared. Now I'm going to simplify this down as much as possible. I think that is an important thing to do before you enter it into your calculator. So times 5 square root x, 1 plus 25 over 4x dx. And then I'm going to go ahead and multiply that x. Since they're both square roots, I can multiply the x through there. So times 5, let's just make this 10. So 10 pi square root of x plus 25 over 4. So that simplifies out pretty nicely too. Now we can go ahead and integrate that. So 1.8 to 3.5. And enter all of that into your calculator. And your final answer should be, should have got the right one, 159.26796. And that's your example, last example. And we're almost out of time too. That worked out just right. So that is how we find the surface area for an object that is revolved around the x-axis.